Hey everybody, and thank you for joining us here today for a SOLIDWORKS ECAD solution, SOLIDWORKS electrical presentation on, that's exactly right, SOLIDWORKS electrical. Design intelligently, design collaboratively, and design successfully. So to introduce myself, I'm on the right-hand side there, JP Emmanuel. I'm an industry process consultant with Dassault Systems SOLIDWORKS. My counterpart, Thomas Smith, who happens to be on vacation, but you know what? I threw his name up there because between the two of us, we cover North America, as far north as you can go, and all the way down into Mexico. And we are the two main electrical experts here at Dassault Systems for the SOLIDWORKS electrical product. If you're new to the SOLIDWORKS brand or the Dassault Systems SOLIDWORKS brand of tools, right? Today we're of course we're talking about electrical. Most folks on the call probably know about the 3D tools, right? They've been around for a while, but then there's also the simulation, all the collaboration, visualization. There's a lot of other tools and they all collaborate and connect together, making your jobs, your team more successful as you finish your projects. So I always like to start off with a little icebreaker here. This is, if I had to name this drawing here, this image, I like to think of it as as what a mechanical engineer is picturing in their head when they're talking to an electrical engineer. My favorite part is actually the flux capacitor down here in the bottom left. So the typical design process that we see that I notice, visiting my own personal experience and what I've seen from customers and prospects alike is that we're drawing out our blocks and we're adding lines to those, and then we're adding text boxes everywhere, and then we're taking that information and we're using something like Excel, right? Something that's not connected to the drafting tool that we were using. And then we still have to go back in and we have to audit that or second check that or even third check that process and make sure everything is working correctly. Well, that process is pretty, I call it the vicious cycle, right? If there's a change that has to happen, you have to now check the schematic, check the documents, the spreadsheets, and then go back in and make sure that all that auditing is done correctly again and again and again. Well, what SOLIDWORKS Electrical allows you to do is it allows you to take a lot of that back end reporting and that a lot of that back end auditing and bring it up front while you're doing your design. So the design itself may take a hair longer in the fact that when you drop in a block or you drop in a symbol, you're going to be adding metadata to that information. But on the back end, you're not going to sit in front of Excel for 6 days making sure that you've got all the right pins for your connectors. The major piece or the key factor, as I like to call it, of SOLIDWORKS Electrical is our shared library, right? This particular window that we see here is one manufacturer part. And inside of this particular manufacturer part, there's a lot of different information that we can actually collaborate with, not just our schematic itself, but there's other pieces of information such as our line diagram, the detailed schematic symbol, the 3D model, or even a 2D footprint. So these graphical representations of this are all tied back to the manufacturer part. So if I need to make a change or add information, adding additional metadata to my manufacturer part, I can push that information out to all of those different examples that we see on the right-hand side. The other major piece of the puzzle here is the SOLIDWORKS connection to the core SOLIDWORKS, the SOLIDWORKS electrical connection to the core SOLIDWORKS 3D that most people probably have heard of. And what I mean by that, if we notice in the middle of the screen there is what we call our component tree. And that component tree you can see is activated on both the electrical side and on the mechanical side. And it shows that P2 that I have highlighted there with the green box around it is the same component on each side. Now, why is that important? Well, if I'm the electrical engineer and I'm going to go ahead and add a pump, I've added P2. Now the mechanical engineer, how does he know or she know that that part has been added? Well, it's added to that component tree you see on the 3D side. And now all I need to do, if I remember that key factor slide that I just showed, if I have a solid model associated to that, all I need to do is say insert, and it will give me the appropriate model and allow me to make that up as necessary. But that's not it. If I'm the mechanical engineer and I know exactly what pump or hose or motor, whatever it may be that I'm working with and I need to use, right? Most times that stuff might be spec'd out on that side of the house. Well, I can go ahead and create that component in my component tree. And now the electrical engineer, all he needs to do or she needs to do is go in and insert P2 from the symbol that is associated to that manufacturer part. It helps us get our job done just a little bit faster. So what am I going to show you today? What are we going to focus on today? Well, we have this box here, right? This 3U chassis. And we're going to go ahead and continue our 3D design, and I'm going to show and utilize some of the 2D functionality that we have, the intelligent 2D functionality that we have within the software. And then I'm going to go ahead and after we work in the 2D space for a little bit, I'm going to show you how that link connects to the 3D side and show you some of the things you do have to set up in order to get those things like the routing capabilities to work properly. And then we're going to go ahead and automatically route our wires. And then, of course, the meat and potatoes behind everything is generating things like our bill of materials and our to from wireless. All that reporting, all those project deliverables that we need, why we created all this, to be able to pass off to the shop floor, to our customers, or just to have as a reference for future use. So with that said, right, we're going to be working with that chassis, but everything that I'm going to cover today, all of the different pieces of functionality and features I'm going to show you right now, it doesn't have to be the 3U chassis. In this case here, we have a frozen drink machine and we have another smaller chassis. It could also be a large assembly such as this with a larger cabinet or multiple cabinets associated to it. So don't get your head wrapped around the graphical representation I have, but more so the functionality and how it can apply to you and what you're doing in your day-to-day job. And finally, of course, those deliverables, including things like a harness drawing. All right. So let me jump into SOLIDWORKS. So I am now on the SOLIDWORKS 3D side. I wanted to give everybody a graphical representation of what we'll be working with. When you're looking at a schematic, all right, a lot of times, what is this really connected to? So here it is. This is what we're going to actually be working with and why we're drawing out all these wires, and we're going to go ahead and route this later on. But before we get into the 2D side of the house, I want to just talk about what we have here on the 3D side and what's available to you. So you'll see this again in just a minute when we jump into the 2D space, but this window that I just popped up here is called our Electrical Project Manager or Management Tool. And we can see that I have a couple different projects that I have available that I can go ahead and open. Well, the nice thing is that this is the handshake or the connection between the electrical and the mechanical side, right? This is where all of our projects that are going to have both of that type of information, this is where we would open and control and save and archive off is a term that we use for SOLIDWORKS Electrical, essentially create a zip file for it. And save that information off for later use. But the one thing I wanted to point out is the fact that you can see that I have it and it's in blue. Lets me know that I have it open because SOLIDWORKS Electrical is a multi-user environment tool. I can have more than just myself working on this, right? Myself and Thomas, the picture of the other guy that you saw on the slide I showed earlier, we can both be working on that same project, whether we're both working electrical or one of us is working electrical and one of us is working mechanical. So with that said, taking a look at the actual project structure, yes, to answer one question that just came in, you can connect this to PDM. I did not show that. I unfortunately do not have that add-in, that executable set up in my environment right now, but yes, you can connect your assemblies, of course your assemblies to PDM, but your electrical projects to PDM as well. But moving a little forward here, we have our document tree. We can see here on the right-hand side, this is just how I created a document tree for this particular project, right? It's very basic. I have a book and I have folders within that book, and I can even take that a step further and maybe have folders and subfolders and even subfolders of that. In this case here, I took my line diagrams to put them in one folder, schematics in another. Maybe you want to put your power in one and your comms in another and hydraulics in another, pneumatics in another. It's totally up to you on how you and your team, if you have a standard already, we can help you build that into the way your projects are structured inside of SOLIDWORKS Electrical. But one of the really nice things about this tool here, the fact that I'm on the 3D side right now, and I can see these documents here available. I can't edit them, but it does allow me to open that and kind of see the progress that the electrical engineers are making with each one of those schematics. Maybe I have a quick question about what part is what. So now I can see the, in this case here, I have my socket modules and I can see that they've been named T1, T2, and T3. The other really nice thing that I when I first started using the software, I thought was really awesome is the fact that I can embed spec sheets right into the project, or just an extension so that if I have a folder somewhere on my server, right, I can point to that particular PDF. Nothing is more, for lack of a better term, annoying when you are in the middle of a project and all of a sudden you're like, oh, I got to go find that spec sheet again. You got to log into a website, or you got to go somewhere on your computer and you forgot where you put that file, that PDF file of the spec sheet, right? You can download it the first time, embed it in the project. You have access to it, and everybody else on your team also has access to that PDF document as well. So if you need to go out in the field and somebody else is continuing the schematic and they don't know the wiring for it and the pinout, well, guess what? It's there, it's ready to use. All right, so moving on, we have the 3D site open. I'm gonna go ahead and I am going to open up a brand new instance of SOLIDWORKS Electrical. When I first open up SOLIDWORKS Electrical, guess what? We see that projects manager that we saw before. And notice the second project that I have open there, I happen to open up another one. The last one you open is the one that's going to be the most current one at the top of that list. I was messing around with that other project right before we started here. But we see here that I have that 3U chassis design that we'll be working with, and it's in red this time. Well, why is it in red? It lets me know that somebody else on my team is also working on that project. In this case here, it's me, because I have my mechanical side open and I'm also going to open the electrical side. But again, if this is a multi-user environment where I have more than just myself working on this, it's just a nice, giving you that nice warm fuzzy feeling, letting you know that, hey, if I make a change right now, somebody else, it might be affecting somebody else downstream as well. Doesn't stop me from opening it. I go ahead and I can see that same file structure that we just saw over on the mechanical side. So once we have the project open, now there's a few things that we can work with inside of this particular project, right? I talked about our line diagrams, our schematics. Now there's a couple different kinds of sheets that you have available to use within your projects. Line diagrams, right? Block diagrams, high level overviews. Just taking a quick look at what those look like here. You don't have to, you can add a graphic representation like you see here. So there's different options. Nothing says you're set in stone. You don't have to do it like this. We kind of guide you in this path if you want to do that and show those graphical representations. But again, to each his own. It all depends on how deep down the rabbit hole you really want to go with this kind of information. But let's go ahead. That's just what a line diagram is. And let's go in and take a look at our detailed schematic as well. Awesome. So one of the first things we're going to go do in this detailed schematic here is we're going to go ahead and draw some basic wires. So I should have deleted them before, but now we're going and I'm going to just draw a few different wires, different wire styles that we have here. So if you notice in the top of the screen, I'm under the schematic tab. We have two different options, right? Draw multiple wires and draw a single wire. What's the difference? Well, the main difference between the two is if I'm doing large cabinet design, or if I'm doing and not necessarily even large cabinet design, but if I have a large bus that I need to draw out, right? I don't want to have to draw all, phase 1, phase 2, phase 3, protection, everything. I can draw that all in one shot. So that's what this is for. You can define each one of those legs. You can turn off a leg. Maybe in one case you have phase 1, phase 2, phase 3. Another case you're only using phase 1. Well, you can check those on and off as necessary. In this case here, we're going to go ahead and just use the draw single wire. And I am going to search for the appropriate wire type that I want. So let's go ahead and find that 5 volt. Oh, turn that guy off. I only want one, not 12 of them. And actually, I think I want AC for that, not DC. So staying in the command, I'm going to go ahead and draw out my 3 lines here. So it makes it a little easier so you don't have to constantly go back to the command manager, we call it, and draw all your wires out. It keeps you in that command and allows you to less mouse movement, getting your job done a little bit faster. So you saw how quick and easy that was. Well, one of the really nice things about the wires, right? In SOLIDWORKS Electrical, we call them wires. They're not lines like you might use in another tool. Well, if I were to go do this, and there might be people out there who have experienced this before. I know I have with other tools when I'm trying to create my to from wire list. And I go ahead and let's say I have this little segment here, right? And I have this red segment. Let's make it a little smaller actually, right? I'm drawing, I've edited a whole bunch of stuff. I've moved stuff around on my schematic, and this little segment just ends up right over the top of this, and I don't even realize it. And then I'm trying to generate my report, and I can't figure out why that wire is not working correctly. Well, SOLIDWORKS Electrical absorbed that wire type. Again, it's not just a line, it's not on a layer in this case, it's on the layer 0 for SOLIDWORKS Electrical, but it's recognizing that that is the same wire type, the same properties behind it, and so it absorbed that little segment because it knows it's not connected to anything. The other thing to notice about our wires is that there are a lot of properties built into every single wire style that we have in our software, which is based on each project. We can talk about that later if you'd like. But right now, I just want to show you the fact that, yes, it's a red line. It's a continuous line. There's a formula, which we'll get into. But more importantly, if I were to go and create a report, or if I were to route this in 3D space, we can see that I have actual physical information associated to this wire type, right? It's a 2.4 millimeter diameter, 16 gauge. Obviously, those can change depending on your manufacturer or whoever you get your wire from. And in reality, is it a white wire? Is there a bend radius? Maybe it's fiber, or maybe it's pneumatics that we're working with right now. So those are important things we need to focus on, especially when, like I said, fiber or pneumatics or anything where there's a tight bend, right? That maybe something like a 12 gauge wire. Obviously, you're not going to be able to make a 90-degree bend with that pretty easily. So moving right along, after we talk about our wires, let's go ahead and work with some symbols. And how do we add symbols to our schematic? So I'm actually going to go ahead and replace this. Just you can see what's there. I'm going to go ahead and re-enter that particular part. Now there's a few different ways I could do that, right? Every engineer's favorite feature and their hand cramp, Control-C, Control-V. I can very well go ahead and do that, but I'm going to show you how you would do it without using Control-C, Control-V. In this case here, we have the ability to use insert symbol, or we also have an option where we can go in and find terminal block. And let's see if we get anything to show up. If it doesn't, then how about we just try terminal? I can't remember what I named this particular item, but if I do a quick search, I can find a couple different items. I can't remember what I named this particular one, so I know where it is. I'm gonna go ahead and search for it. And we'll notice that it automatically filters to my connectors here because that just happens to be the last symbol that I used. But more importantly than filters, these are the classifications that we can store all of our different types of symbols and our manufacturer parts, which we'll get into a little later. But you can see here, most of these are hard coded to the software, right? There's a connectors classification. So if I'm going to add a new symbol or create a new symbol, this is where I would want to store those connectors. You can also go ahead and add new categories under the library management features, where maybe I want to break my connectors library down into jacks and plugs, or maybe Molex connectors and Amphenol connectors. The sky's the limit with really starting to organize this stuff. And then from there, once you get this information in there, now you can go in and start to filter out and find exactly what you need every single time as you move through the software. So I'm going to go ahead and find that part. If I can remember where I put it, I thought I did. Maybe I didn't. I might have to do my old Control-C, Control-V. So let's go ahead and grab that, and I'll drop that into place. From here now, I'm going to go ahead and simply call this T4. Notice it did not overwrite T3. I'm selecting an existing component to match everything about it. And just like that, I've now created a T4. At this point now I can go ahead and I can add manufacturer part information to this. If you don't want to do that and you do want to do what I said I was going to not do, right? I can go in and just do Control C, Control V, and just like that, it also captured all the metadata, and it knows that the one number that was not used was T4 before. Okay. So let's take this a step further, right? I added a detailed schematic symbol about this T4 here. Remember that high-level overview drawing I showed? Well, let's go ahead and do that same thing. And I'm going to add a new one to my line diagram. But notice T4 exists already. So it automatically jumped it up to T6. It's not going to overwrite or duplicate a symbol. And by doing this, it's adding those parts to your manufacturer, your bill of materials for this particular project. I don't want this to be T6, so let's go ahead and take a look at those symbol properties. And I'm going to go ahead and say, I want this to match T4. So by doing that, now I have two symbols associated to this socket module. Now I can use this awesome feature here called Go To, kind of like a hyperlink, where it allows me to just simply go back and forth between these two. Now, why is that important? Well, in this case here, it's just two symbols, but maybe I'm working with something like a PLC or a 30-pin or 50-pin connector, where in most cases, and even in my experience, getting 30 pins or 50 pins or an entire PLC on one sheet is not always the easiest thing to do. You want to put a couple pins there, a couple pins on this sheet, so on and so forth. But you have to remember they're all tied to the same component, and using that Go To feature allows me to quickly go back and forth between all those different symbols throughout all the different sheets I might have in my project. In this case, I've got, 10 sheets or so in my project, but some projects, some customers that I've worked with have 500 to 1,000 sheets in their project. So having that feature definitely helps find things a lot easier as you move through the project. From here, of course, we can go in and now we can add a line, a cable, just to let everybody know that's worth looking at this, that we have a connection from our power supply to our socket module. All right. So now that we have our symbol in here, let's go back to that first sheet where we drew those wires. And let's talk about other than just some of the basic functionality, right? Drawing wires and drawing symbols, that's basic stuff. We can do that all day long. But what does SOLIDWORKS Electrical offer to make my life even faster and without having to use the Control-C, Control-V feature all the time? Well, SOLIDWORKS Electrical, one of my favorite features in the software is the ability to create a macro. Well, what is a macro? Well, a macro for SOLIDWORKS Electrical, not an Excel spreadsheet macro like most people automatically think of when they hear the word macro. It's a common schematic, something that you can use over and over and over and over again, and not just for this project, but every project going forward. So what do I mean by that? Well, let's say I have this power supply here, right? That Vicor power supply, you saw the PDF pop up earlier in the project. Well, this power supply, right? It has its part number, and I have 4 connectors on there, and it has, which are Molex microfit connectors, and it has their pins associated to it. But this particular power supply also requires this 820 microfarad hub in order to generate an output power. Well, that's all well and good, but it also has connectors and it has pins on it. So every time I want to use this power supply, I have to draw the power supply, add all the connectors, add all the metadata behind it, draw all the wires associated to it. It could take some time to do that, right? So why not go ahead and use macro capability? So I've drawn it one time. Now the next time I need to use this, well, I'm going to go ahead and take this, drag it off. I can give it a new name. I can call it Vicor or Vipac, and then give it the actual part number if I needed to, put it in a specific library, give it a description. And just like that, now I've saved it off into my macros library. Now, if I go ahead and take a look at my macros, we can see, even though it says error because I have an error with those wires associated there, you can see that I have all the information here. You can see I have all the metadata built into this particular macro, right? So instead of just doing copy paste, which when you shut your computer down, it's gone, right? In this case here, it's saved off to our database. our collaborative server that all of our users can use, all your team members can share, right? Nothing says it has to be just this one power supply, right? It can be just the one connector with a couple wire types coming off of it. It can also be an entire schematic sheet if you wanted it to be. It could be multiple sheets with your project. So it's just an easier way to make sure that all that information that you've already created the first time, that you can reuse it and keep the intelligence that you've put into it and all that effort you put into it the first time for future use. So one of my other favorite features is obviously something that is used quite a bit is origin destination arrows. Well, SOLIDWORKS Electrical has a really nice way of utilizing the origin destination arrow feature. So in this case here, we have a couple wires not connected to anything. So let's go ahead and use this particular tool. Let me go ahead and pick the right symbols I want to use. And let's go and make sure we find the appropriate sheets for our connection. So we can see here, I have my yellow and I have a yellow on this side on my circuit board. So there's two different options you can use, single insertion or multiple insertion. There is also auto connect. I'm more of a fan of old school style. I want to know exactly where it's going. I don't want the computer. I don't want to rely on the computer for everything. I want to make sure I know exactly where each connection is going. Give myself that warm fuzzy. So I'm going to go ahead and use single insertion. And notice when I select the yellow wire, if I even try to come close to the black wire, it does not let me select the black wire, because remember those properties built into the wire styles. It's knows that, and it's not going to let me cross connect something by mistake, right? Most of us have probably been on a Friday afternoon. You're trying to get a schematic done because there's a project deadline, and mechanical engineers took forever. No offense to any mechanical engineers on the call. I just like to poke fun every now and again. But let's say they take forever to get something done, and now you have to, scramble to get something out the door. Well, this will help prevent those issues that you missed in the schematic initial design, and you don't want to catch 2 months down the road when you're doing the installation out in the field. So I'll go ahead and connect these up. And I'll do the other one. And just like that, I have my connection. Now, it doesn't have to be this arrow. You can see I have a different arrow style here as well. But the really nice thing about these as well is that when I simple double click, it will take me to the opposing page. This is also hyperlinked in the PDF. So when you are done with the project and you export this to a PDF, these are hyperlinked in the PDF. So if you've ever been in the field and you've got the giant 11x17 book and you got your fluke in one hand and you're trying to wring something out, instead of having that big book, now you can have a ruggedized iPad and just double tap, and it will take you from page 2 to page 49 without having to flip through every single page to find exactly what you're looking for, which I find is even more valuable. It may not help you as the designer right there sitting at your computer, but it's certainly going to help whoever's out in the field trying to do all the testing. All right. So taking this a step further, we also have some other features regarding terminal blocks. All right. Now, terminal blocks, not everybody uses them, but I think this is a really great feature, especially for folks who are using them and doing a lot of automation equipment. I've designed cabinets that have no terminal blocks. It's just straight through discrete wiring to cabinets that have multiple leveled terminal blocks built into it. So in order to add a terminal block, well, we have a couple different options that we have available here. So one is insert terminal, and that's just adding a single terminal at a time, or insert end terminal. Well, insert end terminal allows me to go ahead and drop in several terminals all at the same time. That little arrow that you see appears allows me to select what side I want pin 1 to be on, or connection point 1 of that terminal to appear on. And just like that, I could now go ahead and create a new terminal block. And based on the symbol that I used, it gives me the origin destination information for where that is going. Obviously, it's right here. We can see these connectors. But let's go ahead and take this a step further, right? We've added our terminal block. We've added some information to these. So let's go in and for no reason whatsoever, let's go ahead and take these and let's turn this into a cable, right? Because if you recognize the OW, the O, that's probably a Cat 5 right there, right? So I'm going to go ahead and take this and turn this into an actual cable. So SOLIDWORKS Electrical, when you go ahead and take your wires, you are administratively taking your wires and turning them into a cable. You're not drawing it again. You don't have to do this, but this is just an easy way to take what you've already created and just say, hey, software, hey, SOLIDWORKS Electrical, I want you to go from a wire, I want you to go to and turn into a cable. It's very simple step. We're just going to go ahead and highlight these and say associate. And just like that, I now have wires on one side and cables on the other. Okay, so now that we've done that, let's go ahead and take a look at what that terminal block looks like. So in the case of this particular terminal block, I have a lot of different wires. You can see that cable that I just created, and we have the ability to now add manufacturer parts and associate manufacturer parts to our terminal blocks. Well, that's great. So maybe I want to add, I'll do it down here to not mess with the cable, but let's go ahead and say I want to define a level. Maybe this is a 2-level terminal in this case here, right? Or maybe I have end caps or some sort of anchor that I want to add. So I'm going to go ahead and drop that into place, and they are drag and drop. There we go. Do another one. Let's put one at the back end. Come on, let me grab it. There we go. Maybe I want to add a couple bridges in here, so I'll go ahead and create a bridge. Let's do another one between those three, like that. So I have some bridges. Let's say this one is a manufacturer part. Let's see what kind of manufacturer parts I have in my library. 1492J3 sounds like a good one. And just like that, I've got some information in there. Great, so it's an easy way to be able to manipulate everything about that terminal block in one screen rather than jumping all over our schematic to add manufacturer part information to every single one of our terminals. Well, why is this important? Why did we want to go ahead and create all this information? Let me close this guy out here so we can see. So by doing this, the next step that we have the ability to do is go ahead and generate a drawing of that terminal strip, an automated terminal strip drawing. So I'm going to let the software look at our schematic, look at this management tool here for this terminal strip, and it's going to go ahead, and if you notice on the left-hand side, it just created a new drawing in our project. So let's go ahead and take a look at that. And we can see that I now have a terminal block drawing that was automatically generated. Obviously, graphically, I would want to come in here and clean this up a little bit. But you can see here that I have my terminals, right? And I have my wires coming out of the terminal, turning into a cable, giving me some information about that cable, turning back into wires, all the cores of that cable, and then it's going to the connector, right? So maybe there's multiple pieces, multiple destinations that this cable is going to. Maybe it's different sensors that we have out in the field, out in our plant, whatever we're working on that we want to work with. You also can see the levels that we have here. You can see the bridges that we have, and of course the accessories that we added at the end. So there's a lot of information built into this particular drawing that I simply clicked 2 buttons and said generate that drawing for me, and it took all that information in this drawing here with all the cable information, and it created for me automatically. All right, so now that we've gone ahead and we've created that terminal block drawing, and I do see a lot of questions about terminal blocks. I will try to answer those at the end of this session here. There's a lot of questions coming in. So, all right. So now let's go ahead. We have our schematic here. We have our. It's pretty much done. There's a couple things we could probably do to help clean it up. We do have some harness stuff in here. We can work with too later on. But let's go ahead and jump into the 3D space. All right. So back over on the 3D side now, there's a few things that if you're going to try to go ahead and route on the 3D side, or even just connect your 3D side to your electrical side to make sure that the parts are matching, and make sure that the mechanical engineer knows that I've added new connectors, or that the mechanical engineer is letting the electrical engineer know that they added new motors, or whatever it may be. It's always a good idea to make that connection. Well, again, remember that bidirectional slide that I showed earlier? Well, these are all the components I have in my component tree from the electrical side. And if I click on most of these right now, most of them are already connected to a part that I have in my project, whether it's this RJ45 connector or these socket modules, or even this entire box here, or this EMI filter. Me as the electrical engineer, I most likely know which connector is the right connector, right? And I know which one is going to be what, right? This is the input, and the 3 outputs for this. The mechanical engineer might come in and say, all right, give me the models, and I'll mate everything up for you just to make your life a little easier. Well, if I go ahead, and there's 2 options with adding or inserting your parts to your assembly, right? Like I just said, the mechanical engineer can take all those and start putting everything and slapping it in and mating everything up, but might not know what is what, right? There might be 15 of the same exact connector. So in this case here, I'm going to go ahead and find my power supply, and we notice that I have PS1, which is this one down here in the back here, right? If I go ahead and highlight this, it highlights the entire part, right? But notice there's a little checkbox there. These are the pins for it. You don't necessarily have to add the pins, right? The pin, if you're going to go ahead and add pins, I would recommend let's have a conversation before you start trying to add pins, because the more detail you have, and you're never going to see the pins in the actual full external part of this, right? It's just taking a lot of resources out of your computer, especially if you're going to try to route things. But if you need to do it, let's have a conversation first before you go down that path. But if you notice here, my second one here, PS2, does not have a checkbox next to it, which means that there's no model, there's no handshake between a model part and the electrical schematic. So in order to make that, we have 2 options. We can insert, right? Remember that key factor slide I showed earlier, where we have the ability to insert a part. So it's going to go to my library, find that model, and pull it into my assembly. And from there, I can go ahead and mate things up. But the mechanical engineer has already gone ahead and inserted all and mated everything up for me, so I don't have to go and do that. So there's this associate functionality where I can go in and just say, oh, all right, associate. I know that this one right here is PS power supply 1, plug 2. So I'm going to go ahead, and you notice that everything else becomes transparent. I go ahead and highlight it. I hit my enter key, and I've made that handshake between the 2 sides for that particular part. Now, why is that important? Well, that if I'm going to go ahead and try to route anything, the software needs to know where it's going to go to from, right? The software needs to know this is where the wires are going to start or end as we go through our project. So that was one step of the puzzle there when we go to connect things to the route and go ahead and route anything. The other part of it, let's go ahead and take a look at the actual model. We have to be able to tell the wires exactly where we want to route to, right? There's different functionality, there's different pieces of information. In this case here, I didn't do all of them. Let's see if I can make this a little easier to see here for everybody. Oh, that's not good. There, it might be a little bit better. Notice those arrows. There we go. Notice those arrows there. Those are the connection points for every single one of the wires that I'm going to route. In reality, I probably should have created connection points for the entire top row as well, but this is just a demo just to show you how the wires will route at some point. But you can see that those numbers there correlate exactly to the manufacturer part. So when I put a wire on pin 1 in my schematic, on my schematic symbol, this is exactly where it's going to route to. And for those, not to get into teaching mode, but I like to do that every once in a while, right? In reality, where is that wire going to be? Is it going to go right to the face of this? No, that wire is going to be inside of a pin, crimped inside of a pin all the way down here. So in reality, I probably should have put those pins down here, which will give me almost an exact measurement and a length, which we will capture later on, of those wires from point A to point B. All right, give this a second to close that file. All right, so now we're just about ready to route. But there is one more step, but I'm going to show that after we actually route our wires. So I'm going to go through, route everything up. There's a couple different options for routing. In this case here, you have a full solid route. It's going to give you the full thickness of every single wire. And we have sketch route. I'm going to do sketch route to save us all a lot of time, so we're not sitting here twiddling our fingers while we're looking at this. You do have the ability to use splines or lines. Obviously, splines will give you a more realistic view. And then you have the ability to route everything in one shot, or maybe you're concerned with just one section of your project right now. Maybe it's not everything that you need to route. I'm just concerned with how things are going to flow in this case here. So I'm going to go ahead and select, and I'm just going to go and pick the socket modules here. Pretty much everything's connected to those anyway. There's a few outlying wires that we're going to go do. And then there's some parameters, which we'll explain in a little bit. So I'm going to go ahead and route this. Two of my parts are lightweight parts. So if you're familiar with SOLIDWORKS, you can see those circuit boards, those single board computers that I have in the bottom right. They're pretty heavy. They're pretty, they take a while. They chug along when you try to open those. So I tried to put those in lightweight to kind of speed this up a little bit. So sketch lines, what it's doing right now is, after it did that lightweight resolve, is it's looking at my models, right? It's looking at the schematic, and it's trying to determine pins 1 through pins whatever it may be, and routing from point A to point B. It's using the schematic to figure out the route. Now, the last step I said that we didn't show yet, that I didn't show you yet, is our guideline, right? We can go ahead and route without a guideline, but the software is going to route where it wants to route, not where you told the wire to route. So if you have Panduit or some sort of wireway over the top of a whole bunch of cabinets, stuff like that, it's not going to follow that because you didn't put that in. So there is what we call an EW path. So I'm going to let this finish here. And it should be a result here in just a second. It's thinking. There we go. It's trying. So again, it's going through, it's looking at the schematic, it's comparing the pinout information I have from the manufacturer parts of my schematic to the information I have in my models, and it's routing everything for me. And you'll see this EW path that I just mentioned, that guideline, will appear because it's just a 3D sketch. It will appear when the sketch routes are done. I see a comment there. I like the associate feature. That I love it too, because if I'm trying to work on a project, if I'm quick now because I've been doing this for a while. As far as inserting and mating things up, I even have a space wheel that I'm still getting comfortable with. But having that associate feature, I can see, hey, just mate everything up. I'll go in after you, and I'll just, this is power supply 1, this is power supply 2, this is VFD 1, VFD 2, so on and so forth. So now you can see our route. Now, it looks crazy because I have this guideline. Now you have to remember, this is a demo data set right here. So that yellow line there is used to, to make it look super clean and pretty, right? It doesn't always have to be this obnoxious, for lack of a better term. I laugh at myself because it was like one of the first times I was doing the EW path, and I just went nuts with it. You don't have to go to this extreme with it. If it's Panduit, right? And if you're doing a cabinet and it's essentially a figure 8 position, you've got a top row, there's one in the middle and one on the bottom, and a couple side rails too. That's all you need. You need a line, right? It's just a 3D sketch line to tell the wires that I want you to follow this path. On top of that, there is an option for segregation, your power versus comms, right? Maybe I want to do all my power on one side and all my communications on the other side of the cabinet. You can tell the software that you want to separate those out and break those out as necessary as well. I'm going to go ahead and hide that EW path so it's not in our face, and we can take a closer look at those lines. Give it a second. There we go. And you can see for the most part here that we've got our +5s, a couple of our commons. We have our 12s, and I believe, I can't remember what I made this, 3.3, or maybe it was 48 volt. But those are some of the sketch lines we've got for our project. Now, if you do need to edit those sketch lines, right, I would absolutely recommend you edit your EW path, that yellow guideline that you just saw, to force the wire to follow that. you do have the ability to simply right click on any one of these sketch lines and edit the path. However, if you do reroute those wires later on, that information is gone because you manually did it and it's going to override that. So if you're going to manually manipulate anything, I would wait till the end, make sure it's nice and clean, make sure it's what you want, and then go from there. All right. We do also have, that was wiring, right? There is also the ability to show harnessing and cabling, which are two additional setups, right? Remember I said earlier that there is the administrative setup where you take your wires and you administratively turn them into cables. Same thing applies to our harnesses. You're going to administratively take those connectors, those wires or cables, and turn them into a harness. So each one of those is just a different layer on top of each other that you're going to use in order to route. Now in the case of this, I've already gone ahead and routed a harness, so you can kind of see that it includes the main input power, and it goes to our breaker in the front of the cabinet. From here, I won't get into it right now, but you do have the ability to go ahead and take that, flatten that out, and after you flatten it, you can turn this into a drawing, add balloons, add tables. There's a whole bunch you can do with that, that particular item there as well. If you want to see more on that, we have a whole bunch of videos and stuff on how harnesses and flattening and how that works. If you've noticed, maybe some of you did, maybe some of you didn't, I am running SOLIDWORKS 2022, so shh, don't tell anybody. But I have some of the more enhanced routing features and stuff like that, and it's really cleaned up really nicely in the latest release of this software. All right. I don't have enough time to show everything there, but I can for the few comments there at the end. I will. So the comment was, show us how the harness works. I can show that. I just don't have the time right now. I'm already coming up to the end under the hour here for this, but that's a whole nother webinar that we can plan out and get out there for you. All right. So going back to core SOLIDWORKS electrical now. After we do our routes, there's a few other things that we might want to do and housekeeping that we want to do on the electrical side, I should say. So in the case of our electrical project, let's go ahead and find a good sheet to work with here. Control E is your friend. That's zoom extents. Always zoom out to where you need to go. And let's go ahead and search for a good spot to route or run our numbers, right? So we're going to number all of our wires. So if you've ever tried to number wires in the past, well, numbering can be, especially if you're in the DoD world, right? Everything has to be perfect. Not to say everybody else isn't perfect, but in that world, that's where I came from before this. It has to be exact, and if there's ever a change, it can be a nightmare. So in the case of this software, I'm simply going to go ahead. Oh, wrong button. This one. I'm going to let the software do it for me. And just like that, I now have a numbering scheme based on certain information, certain criteria that I gave it. Well, where did it get that criteria? Where is it pulling this information from? Remember the properties I talked about, and there was a formula in there. Well, every one of our wire styles, whether it's an RF line, whether it's a pneumatic or hydraulic line, whatever you want to call it, you can set up a formula specific to that exact wire type, that wire style. If you wanted to say it's 5 volt to 5 VDC, 120 VAC, whatever you want, and in this case here, it shows the W number in front of it, so be it. You can have that. To each his own. If you have one thing that I get a question about every single time is a lot of companies do reverse engineering, or they're adding on to an existing project. There is functionality where you can say, do not delete manual numbers. Maybe you've gone ahead and you're not allowed to change, wires 1, 2, and 3 because those are already there and are approved. Well, you're going to go ahead and manually name those, and now you're going to make sure that you uncheck this. It's already unchecked by default. I was messing around earlier on another project, but you can have this set up to not delete those and leave all those manual numbers alone. So once you have your numbering scheme set up and you route everything, if you ever need to change anything, well, oh, the mechanical engineers came in and said they need to move 47 things on you, so you might as well just renumber everything. Well, I just deleted it. I can go ahead, renumber. I'll take a sip of water real quick. And just like that, my project is renumbered from top to bottom, left to right. So now that we have that information in there, the next thing we want to do is we want to generate some reports. So there's two different types of reports. We talked about that auditing capability, and of course there's the reports like to from wireless. Well, there's the reports, bill of materials to from wireless, wire run list, whatever you want to call it. And then the design rule checks are things like your voltage drop for cables or a fill duct ratio. This is all information that you can have metadata, right, that you can compare within your project to make sure that you're getting the proper output. Do you have too many wires going to one pin? Maybe you have a 14 gauge wire going to a contactor that can only accept a 16 gauge wire, right? So those are things that we'll check for based on what you drew out in your schematic. So jumping into reports, we have a couple different kinds. The software comes with about 30 different default reports, different ways to set them up if you need to. They are totally customizable. There's a lot of different queries that you can create and customize to make every single report your own. In the case of the reports, before we even add it to our project, we do have the ability to just simply export to Excel from here. So maybe you're doing something like your wire labels. Maybe you've generated a custom report for your wire labeling numbering scheme, right? And you can generate that, push it out to Excel, and now you can import that right into your Brady printer, Mitsubishi printer, whatever it may be. You also have the ability to export it to XML and text file as well. All right, so I'm going to go ahead and generate these drawings, and I'll select all of these, and we notice on the left-hand side, underneath our document tree that's still open, we'll start to see some projects, some new sheets appear in our project. I'll give this a second. It's been a while since I've generated the bill of materials for this, so it might take a second to query and pull all that information out of the database for this particular project. Is there a list of? So the line numbering, that comes with the title block. So if you ever hear the term template and title block, those are two totally different things in SOLIDWORKS Electrical than what you might be used to. There is your numbering scheme for your sheets. There's two spots, right? There's two spots to work with that. I can cover that in just a second. But you have your numbering scheme you see here in my title block. But that information can also change from 1, 2, 3, 4 to A, B, C, D, and that is based on the project, right? Because one customer might want 1, 2, 3, 4. Another customer might want A, B, C, D, or maybe you want, 100, 200, 300, or 101, 102, 3, whatever it may be. That is all set up in a formula, and then that is tied to your title block later on. All right, so jumping into our different types of reports, we'll take a look at our bill of materials first. This is a very, very basic view of what the title of the bill of materials is. This is based on the manufacturer, but you can organize this. Maybe it's based off vendor. Maybe you order 40 parts from DigiKey or Mauser, right? You want to put all those together. Maybe you have, maybe you do order directly from the vendor, from the manufacturer. You can do that as well. Automation Direct, right? There's all different vendors you can buy this stuff from. So maybe that's why. Maybe you want to see location instead. Maybe there's location 1 and location 2. Maybe they're identical cabinets, and that's the best way to determine what's in what, right? So you can organize and break out your bill of materials based on that. You can also go in and add additional information such as the actual vendor, right? Right now I only have manufacturer, but maybe I do get this from DigiKey or Newark or whoever I get my stuff from. So you can add those fields in here as well. A list of our cables. You can see all the different cables we have in here. We did not route any cables, so I have a 0 for that, but let's go ahead and take a look at one of the wire reports and see what we get here. I have a few of them. I didn't route everything, so I got to find one that's going to give me a good length here. So there's one. You can see I have the 5 EDC here, and a whole bunch of them did route, but I did, again, remember, I only routed the ones to the socket module. So there's a whole bunch of wires that aren't connected to that directly, that socket module. But overall, the main piece of the puzzle here is the fact that I can capture a total. So if I'm working and I have, this may not be something important to everybody, but there are a number of people who they need to be able to get this information for quoting purposes, right? How much wire did I actually use for this project? Yeah, we buy wire by the 1,000-foot spool, right? Okay, great. But for other people, this is a big piece of it, right? The other part is too, I've seen some companies actually take this. Of course, they add, you can add an extra 5 or 10% to the end of this. You can set up the formula for the length to include that. And now they can take this information and plug it right into their wire stripping, wire labeling, crimping machine. One of those monster Wamadyne awesome machines that does all your wire crimping for you. It's pretty cool. If you haven't seen one of those, they're pretty cool to see firsthand. But if you need that kind of information, you can create all those wires for you automatically, which is really awesome, saving you even more time down the road. All right. So let me jump back over to this guy. So with that said, I covered a lot of information just now. I'm coming up on the top of the hour here. I'm going to try to take 2 or 3 questions before we all jump off here. But what we covered, the intelligent design schematic. My goodness, I can't even talk right now. The intelligent schematic design functionality, the 2D to 3D collaboration, the visualization of our wires. You can see in that image that we have on the screen right now, those are the full solid route. That's what it would look like, not just the sketch lines. And then of course the automated report generation, which is awesome, right? You don't have to sit in front of Excel, like I said at the beginning, for 6 days, making sure you're ordered all the right parts and creating new tables and everything else. It's done for you automatically based on what you put into your project, into your schematic. The SOLIDWORKS electrical difference, of course, is the data reuse, the change management, the design review, and the value of all those reports. I'm going to jump through those real quick. And I'm going to go ahead and if you still want more information about this, please reach out to your local SOLIDWORKS value-added reseller. You can also email us at this address here, or you can just take your phone. If you've got an updated Samsung, iPhone, whatever, your camera will actually just do that. You don't need a special app anymore to do that. So just open up your camera app. You can take a quick picture of that. Not even a picture. I think if you just show the camera what you're looking at, it will take you to Safari or the appropriate browser for that. So with that said, there's that QR code again. I'm going to take a couple questions here real quick. Let's see. So one question I have, I'm going to try to start at the top here, but let's see what we got here. So yes, the wire style can allow for coax. You just have to build the wire style, the appropriate wire style, right? If it's a coax or triax, you might want to use a multi-wire style to include that. If you want further information or you want to talk about that a little bit more, we can go down that path, right? Because you can set that up in your connectors and your symbols as well if you needed to. You're right. It's instead of calling it a macro, right? It's more of a group, but I call it a common schematic, something that I'm going to use over and over again, but maybe a group of symbols. That's just the name they came up with a while ago, and it kind of stuck. So let's see here. So you can show the shrouding or the insulation on a cable. That would be, you would have to route, and then after you route, there is the option of a covering over the top of it. It's not going to give you, like, if you're going to run, we used to call it, pardon my if you don't know what I'm talking about, but you called it snake skin instead of insulation or anything, or the type of shrouding on the outside of it. That is something you can add to your wires, your cables, but it's an additional feature that you'd have to do after the fact. And yes, you can go from Excel to SOLIDWORKS Electrical. So if you have an existing tool and you have a manufacturer parts library or the import features, I did not cover that, but that is something that is important to a lot of people, right? I've created all this data over the years, and now I don't want to switch tools without taking some of that information with me. There is the ability to import manufacturer parts, import your symbols, import information from Excel into SOLIDWORKS Electrical. There is a way to take information from your software, from SOLIDWORKS Electrical, I should say, export it out to a spreadsheet, manipulate it, and then import it back into that project, right? Because there's some people that have additional tools. I've seen this in the nuclear industry where they have to use certain information, certain testing equipment that requires some superwhamidine type of, has to have a spreadsheet associated to it or whatever, and then they have to import that back in. So I've seen that ability as well. Let's see here. Yes, you can get a recording of this video here. So tomorrow afternoon, Christine, correct me if I'm wrong, but tomorrow afternoon, roughly 24 hours from now, you should receive an email with a recording of this webinar for your view or for sharing with your coworkers. So with that said, let's see. I'm trying to see if I can find any more. There's so many questions, I can't even read them fast enough. They're coming in so fast. If we did not get to your question, we do record all the questions. I will try to reach out to you later on with an answer to those questions. I want to say thank you to everybody for coming out today and checking out SOLIDWORKS Electrical. And we had a lot of people today, so that was awesome for a Wednesday afternoon or Tuesday. What's today? Tuesday. Holy cow, I'm getting ahead of myself. So thanks again, everybody. And again, the recording will be out tomorrow afternoon. Have a great day.